Hello my dear friends and students. Dr. Mohammed Parvez here. In the second tutorial of this series, the protein was purified by removing unnecessary heteroatoms and protein chains. In this third tutorial, I am going to repair the missing atoms in the protein structure and then to prepare it for the docking. This tutorial will be completed in two steps. First, to show you how to repair the target protein for the missing atoms. Second, to make necessary changes in protein structure to make it ready for the docking. So first, I am going to repair this protein for the missing atoms. You will find that a large fraction of the protein structure submitted to the protein data bank have missing atoms due to preparation for the X-ray crystallography. This may create issues for molecular biologists during the use of the protein crystal structures. Luckily, the AutoDock tool 4.2.6 has the option to repair the missing atoms. To do this, first we will check whether our research protein has missing atoms or not. To repair the missing atoms, first we will open our protein and MGL tool. Open your protein from your working folder. You will remember that this is we had purified this protein for our docking. Open this protein. This is the 3D structure of our targeted protein. To repair the missing atom and the residue of this protein, go to Edit, Miscs. Down here click on Check for the missing atoms. You can see that 529 residues with the missing atoms. These residues are displayed in this small window. Now you have two options. You can select and repair all these residues, or you can select the current residues. All residues mean that all amino acids present in the protein. As repairing all residues will take more time, therefore I will press select current residues. Select current residues and then press dismiss. Again go to Edit menu, down here to Miscs, and now press repair missing atoms. You can see repair of the missing atoms have been started. Depending on the number of amino acid residues, the repair of this protein will take some time. Usually it takes 4 to 8 minutes to repair a protein chain. So I am going to pause my recording at this moment. The AutoDock repaired this protein in almost 5 minutes. You can see that at the end of the repair, the color of the 3D structure of protein changed. At the end of protein repair, this report will be displayed. Here you can see 550 atoms with close contacts. Now save this repair as 2 sets. Save as 2 sets and dismiss. Now to cross check for the missing atom, I will repeat the steps. Go to MISC again, check for missing atoms. Now you can see that there is no residue with the missing atoms. So I'm going to press dismiss. After the repair is completed, now it's time to prepare this protein for docking. First, we will need to add polar hydrogen to this protein. For this purpose, go to Edit menu, then Hydrogen, and click on Add. You can see that there are two options, all hydrogen and polar only. I will select polar hydrogen because only polar hydrogen can charge the protein. Leave the other option as default. You can see that some hydrogen atoms have been added to this structure that appeared in white color. The second change is to add charges. So to add charges, go to Edit menu, Charges, and click on Add Coleman charges. You can see here that 34.007 Coleman charges are added to this protein. Okay. Always remember to add Coleman charges to protein but Gestiger charges to small molecule. After adding charges, check for charge distribution on amino acid residues. Go to go to charges, and then click on check totals on residues. You can see here that the charges are not distributed equally. There are 4 residues with non-integral charges. The residues are given in this small window. To spread charges equally, you should press this button. Spread charges deficit over all atom and residues. And after this, click on dismiss. Repeat this step to cross-check the charges on the residues. Here you can see no residues with non-integral charges found. This message indicates that the charges are now being distributed on all residues and the protein is now completely charged. To save this protein in pdbqt format, go to Grid, then Macromolecules, and press Choose. In this small window, click on this protein and select molecules. Press OK. You can give the name of your choice to your protein after preparing it for the docking. I'm going to name it REC. For me, REC means receptor, and add pdbqt extension to this name. In pdbqt, Q stands for charges while T stands for atom types. So I am saving this protein as receptor. Here you can see that the color of our protein changed after we save it in pdbqt format. This protein is now ready for docking. At this time, your working folder will have one additional file with the name of rec pdbqt. This is the file format pdbqt file. In the coming tutorial of this series, I shall be demonstrating the preparation of ligands and will show you the databases from where to download ligand molecules. You can watch the next tutorial with the title Thanks for watching and bye till my next tutorial.